Welcome to the first video where we're going to be going back through the trial exam and going through the solutions. This first video we'll be looking at just the multiple choice questions. So question 1. What is the value of the sine of 60 degrees to 2 decimal places? Right, this is a straightforward one, making sure your calculator obviously has the D at the top for degrees. You're typing in sine 60 equals, and it's going to come back as one of those. Well, sine of 60 comes back as 0.8660254. Now it says we want to round to 2 decimal places, so 0.86 is either going to be A or B. Hopefully you realize, well, that second 6 means that we're going to be rounding it up to 0.87. So the correct answer is going to be B. Question 2. The table shows that the average energy used in kilojoules per kilogram of body mass when cycling at 2 different speeds for 30 minutes. So if we cycle at 15 kilometers per hour, for 30 minutes, we're going to use 11.52 kilojoules per kilogram. However, if we're cycling at a faster speed of 60 kilometers per hour, we're going to be using more kilojoules, namely 18.43 per kilogram. Now we've got someone here, Jake, who weighs 62 kilograms. Now, if 1 calorie is equivalent to 4.184 kilojoules, approximately how many more calories would Jake use cycling at 20 kilometers per hour than he would at just 15 kilometers per hour? So we want to look at what's the difference between the two, because it says how many more calories would Jake use. So we're just going to find, well, what's the difference between our 18.43 kilojoules and our 11.52 kilojoules? Difference between the two, 6.91 kilojoules. Now that's per kilogram. Now we know that Jake weighs 62 kilograms, so we're going to multiply that by 62 to find out that Jake, the difference between those two speeds, Jake is going to be using 428.42 kilojoules. Right, that's just the difference. Now, the other way we could have worked this out is we could have worked it out for each individual one. So we could have said, well, for 11.52 and 18.43. So if we do 18.43, which is the 20 kilometers per hour, we multiply that by 62 to find out that Jake would use a total of 1,142.66 kilojoules. And then we did the same thing for 15. So we're going to do 11.52 times 62 to work out that if he was only cycling at 15 kilometers per hour, he would need a total of 714 kilojoules. Again, we want to find, well, what's the difference between those two? Lo and behold, again, we get our 428.42 kilojoules. So it doesn't matter which way you work it out. You can work out what's the total kilojoules for 15 kilometers, the total kilojoules for 20 kilometers, and then find the difference. Or you can just find the difference between those two numbers and then multiply it by 62. Doesn't matter which way you go, you still get the same answer. But note, both of those are in kilojoules and the question says in calories. So we want to use that 1 calorie is equivalent to 4.184 kilojoules. If you need that piece of information, it will be given to you. You're not required to memorize or know that. Either way, we want to go out 428.42 kilojoules and divide that by our 4.184 to work out that it's a total of 102.4 calories. Lo and behold, that's option A. Question 3, we've got a 140 centimeter television with an energy of 7 stars, and that's going to consume 213 kilowatt hours per year. The same size television with only an energy rating of 3 stars is going to consume 520 kilowatt hours per year. Right? The more stars, the less energy it's going to use. Now, if energy costs are 28.55 cents per kilowatt hour, what is the approximate saving in energy over a 10-year period by using the 7-star rated TV compared to the only 3-star rated TV? Question 3, very similar to question 2, we're looking at the difference. So what are the difference between the two televisions? Well, one's 520 kilowatt hours, the other is 213 kilowatt hours. So that's a difference of 307 kilowatt hours per year. So now we want to work out, well, what's the cost? So we want to get that 307 kilowatt hours and multiply that by a cost of 28.55 cents. So that's going to be 8,766.85 cents per year. Note that our question, however, is talking about dollars. So how many dollars are there? Well, we need to divide that by 100 to convert our cents into dollars. So for 1 year, it's $87.67. But that's only for 1 year. The question says, how much is the approximate saving over a 10-year period? So we want to now multiply that number by 10. So over our 10 years, it's a difference of $876.70. So over this 10-year period, we can save almost $900 by using a more efficient television. So the answer is 876, so that's going to be A. Question 4, we've been given this particular shape and we want to identify which one of A, B, C or D is the top view of this particular cube. Now the joy of this question is that what examiners can do is they can just change the wording, because each one of those 4 options, A, B, C and D, is a different view of that shape. So they could say top view, next year they could say side view, next year they could say front view, and they don't actually have to change the diagram. But this one wants to know the top view. So if we were looking straight down, what would we see? Well, we would see those faces there. So we've got 4 faces across the back, and then we've got 2 more sticking out in front of it. So we've got 4 in a row, and then we've got 2 others sticking out. Looking at option A, well, there's 3 and 3, it's not that one. B is also 3 and 3, it's not that one. C is a 3, and then 2 singles, it's not that one. So option D, which is 4 and then 2, well, there's our option. Right, our answer is going to be D. Just looking at it, A would be if we were looking at the right-hand side, B would be looking at the left-hand side, C would be looking at the front. Question 5, the size of the angles in a triangle are in the ratio of 2 to 3 to 5. What is the size of the largest angle? So what we want to do is, this is a ratio question, we want to divide up a quantity into our given ratio. How much do we want to divide up? Well, the angles in a triangle add up to 180. So firstly, the first step we always do is we add our parts together. So we've got 2 plus 3 plus 5, so in total we have 10 parts. Like I just said, we have 180 degrees in the triangle, so we want to divide that 180 degrees by our 10 parts, which means that we get 18 degrees in each one of those parts. Now, I want to multiply that 18 degrees by each number in my ratio. So I'm going to do 18 divided by 2, 18 divided by 3, and 18 divided by 5. But to make my life a little bit easier, the question says, what is the size of the largest angle? So I don't need to do the 2 or the 3, I just need to do the 5, because the 5 represents the largest part. So if I do my largest angle, which is going to be 18 degrees, multiplied by 5, we get 90 degrees. So therefore my option is going to be C. It is easy to look at this sort of question and say, which is the largest angle? Well, 120 is the biggest number there, so it must be 120. It doesn't work with this particular ratio, right? So it is important that you do actually look at what the question wants you to do. Question 6. It is 5:30 p.m. local time in city X, when it is 2:30 a.m. local time the next day in city Y. City Y has a universal coordinated time, UTC, of +4. We want to find out what is the UTC of city X. All right, so city X is 5:30 p.m, city Y is 2:30 a.m. the next day, so city Y is ahead of city X. So city X must have a UTC of less than +4. So straight away we can kind of rule out C and D, it must be either A or B. So we want to know what's the difference again between 5:30 p.m. and 2:30 a.m. Just a quick count on my fingers. The time difference between those 5:30 and 6:30 is 1, 7:30 is 2, 8:30, 9:30, 10:30, 11:30, 12:30, 1:30, 2:30. And if you've counted on your fingers like I just did, you should hopefully get 9 hours is the difference. So if we draw ourselves up a quick number line, city Y is at +4, so I can mark city Y there. Now I want to work out where is city X. Well, city X, as we said before, is 9 hours before that. So 1 hour before would be +3, 2 hours before would be +2, 3 hours before would be +1. So forth, I keep counting down until I get to city X is 9 hours beforehand at -5. Right? Other way we can look at it is we started at +4, Right, that was our UTC for city Y. We then take away the 9 hours, the difference, and that's going to give us -5. Either way, option B is going to be the answer. Question 7. The bearing of Isham's home from her friend Vanessa's home is 230 degrees. What is the bearing of Vanessa's home from Isham's home? So what we're looking here is what's called a back bearing. We know 230 degrees is the bearing of Isham's home from Vanessa's home, but we want to know what's the difference back. So let's start off. Whenever we want to do a question to do with bearings, we draw ourselves a little compass. Right, north, east, south, and west, 0 or 360 at the top, 090 for east, 180 for south, and 270 for west. Now, we know that we want a bearing of 230 degrees, so it's going to be between 180 and 270. 230 is about there. Where exactly is that 230? Well, we know we're going to 180 plus a little bit further round to 230. So what's the difference between 230 and 180 is 50 degrees. So between south and that blue line, that's a 50-degree angle. So that is the bearing from one house to the other. We want to come back. So at the end of that blue line, we're going to draw in another compass bearing. Now, our laws of parallel lines says that 50 degrees on the right up at the top there between the south and the blue line is going to be the same between the north and the blue line on the second diagram. Those are alternate angles. So now then, what is the bearing of that top compass from the second compass that we just drew in? Well, that's going to be on a bearing of 050, which means B. Question 8. The growth of bacteria in a culture can be modelled by the equation n equals 75 multiplied by 1.05 to the power of t, where n is the number of bacteria after t hours. What type of graph would represent this model? Right, so we've got 4 options there, and we need to work out which one it's going to be. So let's just go through and work out what each one of those specific things actually mean. So parabolic. Well, parabolic means we've got a nice parabola shape. Right? So it would be of that kind of format, where we've got something plus something else all to the power of 2. Right? Parabolic, it's going to be squared. Linear, well, linear means it's a nice straight line. There are no powers of any sort. Hyperbolic, well, that's something that only we look at in mathematics extension. That's not in the standard course, so you don't even have to know what that means. What you should realise, though, hopefully, is that when we've got something to the power of our variable, i.e. in this instance to the power of t, it is an exponential. All right, so our answer is going to be A. But just by process of elimination, we are also left with A. Question 9. A movie studio has 6 main attractions labelled A1 through A6, and there is a studio tour connected by a series of walking paths, as shown in that network diagram below. The average walk times in minutes between the attractions and the studio tour entry are indicated. Currently, Miranda and her family are at attraction A1 and begin walking towards the studio tour entry at 10:55 a.m, keeping to the average walking times. What then is going to be the earliest time that Miranda's family should arrive at the studio tour entry? So we're starting at A1 and we want to get to the studio tour entry in the quickest time, so we want to find the minimal path. So if we start at A1, we can travel up to A2, and that will take us 8 minutes. If we go from A1 down to A3, that'll take us 6 minutes. And if we go from A1 through to A4, that will take us 14 minutes. Now from A2, I've got 2 choices. I can go across to A5, which will take 8 minutes. So 8 minutes to get to A2 plus another 8 minutes means I'll be getting to A5 16 minutes after I leave A1. If from A2 I go down to A4, 8 plus 3, that will take me 11 minutes. If I go from A1 down to A3 and then up to A4, well, that's going to be 6 plus 9, which is 15 minutes. A1 to A3 to A6, that's going to take me 16 minutes. Straight away, if we look at A4, I've got 3 options, 11, 14 or 15. We want the quickest way, so 14 and 15 are useless, so we'll cross them out. The quickest way we can get to A4 is 11 minutes. So then if I go from A4 up to A5, we're going to do 11 plus 7, so that's going to be 18 minutes. 18 minutes is longer than 16, so let's cross that one out and not worry about that. From A4 Oh, sorry, from A5, I can go down to the studio entry now from 8 minutes. So 16 plus 8 will be 24. So that's the top bit done. However, if I'm at A4 and I want to go straight across to the studio tour entry, it's going to be 11 plus 14. That's 25. Well, 25 is already bigger than 24, so we're going to cross that one out. From A4 in the middle, I can go down to A6. 11 plus 3 is going to be 14. Well, that's quicker than 16, so let's cross out 16. And then from A6, 14 plus 4 is going to be 18 minutes. Well, 18 minutes is quicker than 24, so let's cross out 24. So the quickest way that I can get from A1 to the studio tour entry will take me 18 minutes. Right, so we've worked out the quickest amount of time that we can get through that network. It says that if we start walking from A1 at 10:55 a.m., we're going to do 10:55 a.m. plus 18 minutes. That's going to get us to 11:13 a.m. So the soonest that I can get to the studio tour entry if I leave A1 at 10:55 is 11:13 a.m. And that is option B. Question 10. A piece of artwork is currently valued at $18,500. It is estimated that the artwork will increase at an annual rate of 5.5% over the next 3 years. So each year it's going to increase by 5.5%. Which of these calculations would give the estimated value of the artwork in 3 years' time? It's not asking you to work it out, it's just asking you to look at each of those particular equations and tell me which one best represents this situation. So straight away, my eye is drawn to C where there's a division. At no point in time have we looked at anything in finance where working out a future value has a division. So C is not going to be one of the options. What we do have though in option A is our amount that we've got multiplied by 1.155. So if we've got an interest rate of 5.5%, we would divide that by 100 and get 0.055. If we added 1 to that, we would get 1.055. So that 1.155, not sure where that comes from, but that top row is starting to look like a simple interest. We don't want simple interest, so it's not A. B, I have no idea where they would get 1.165, but there's nothing there to do with our 3 years worth. So there's no point even looking at that one. Let's cross that one out. So what we're left with is D. All right. On the formula sheet, you should see that the future value, our amount, is going to be the principal multiplied by 1 plus the rate to the power of n. Right? Which one represents that? That's D. Question 11. We have a 5-number summary from collected data, and it's shown below where x is the largest of the 5 numbers. Which value of x would be considered an outlier? So this is our 5-number summary. We've had a certain amount of data. We don't know how much data, but this is the 5-number summary. So hopefully we can all remember what our 5-number summary tells us. Right, so our first number is going to be our minimum score. The second number is our first quartile. The third number is the median. Fourth score is the third quartile. And then the fifth number is going to be the maximum score. So we want to work out which one is an outlier. How do we do that? Well, we're looking at the bigger outlier. So again, looking at our formula sheet, we see that our outlier is greater than the third quartile plus 1.5 multiplied by the interquartile range. So our inner quartile range, well, that's the difference between Q3 and Q1, our third and first quartiles. So those numbers we're just going to get straight out of our 5-number summary. So it's 40 minus 26. So that means our inner quartile range is 14. That's just saying how spread out is quartile 1 from quartile 3. And it's spread out 14. We don't know what this data represents, so we can't say whether it's 14% or 14 of any particular thing. It's just an interquartile range of 14. So now we can work out our outlier is going to be greater than our third quartile plus 1.5 times of that 14. Right, so we know that our third quartile is 40, and then we're doing 1.5 times that interquartile range of 14. So that means our outlier has to be greater than 61. Which one of those 4 numbers is greater than 61? Well, it's going to be D, right? 65. 61 is not going to be an outlier because the outlier needs to be greater than 61. This is the sort of question where we could be lucky and say, well, hang on, 65 is the biggest number there, therefore 65 is going to be considered an outlier. Right? This is one of those questions where we can kind of guess the answer. Question 12. Anna takes out a loan of $250,000 from a bank at an annual interest rate of 4.5%, charged monthly on the amount owing. Anna makes monthly repayments of R dollars on her loan. If Anna owes $249,737.50 after making her first repayment, what is the value of R? So we know our 4.5% is our yearly interest rate annually. So that's for 12 months, but our interest is going to be charged monthly and we're making monthly repayments. So we want to look at this monthly. So we need to work out what is our monthly interest rate. So we get our annual yearly interest rate of 4.5% and divide it by the 12 months to find out that our monthly interest rate will be 0.375%, which is 0.00375 as a decimal. We can just divide our percentage by 100 to get to that decimal number. Now, the way that the balance is worked out is it's going to be whatever was owing minus the repayment, then multiplied by 1 plus whatever our interest rate is going to be. This is the sort of thing you kind of have to get your head around to remember somehow. Ultimately, it's a multiple choice question. You can always guess it. But let's assuming that you can remember this and we can go through it. That's what we're going to do. So our balance, well, that's our $249,000 figure. How much was owing? Well, that's the total amount that we borrowed, $250,000. The repayment is just going to be R, and our interest rate is 0.00375. So if I add 1 and 0.00375, we get 1.00375. Now my goal is to work out what R is, so I want to get R by itself. So what I'm going to do here is I'm going to divide both sides by that 1.00375 so that I'm left with 250,000 minus R on the right. Now if I get that $249,000 amount and I divide that by 1.00375, what I'm actually going to get is $248,804.48 is equal to that 250,000 minus R. So then the difference between those two amounts is what's going to tell me what R is. It's that 25,000 minus that $248,804, and that is approximately equal to $1,200 or $1,200. And looking at our list of multiple choice options, that is option C. Question 13. A network consists of 5 vertices and 7 weighted edges as shown below. Which diagram on the right correctly highlights the minimal spanning tree? So remember, our minimum spanning tree is how can I connect up all of those 5 vertices using only 4 edges, right? One less than the number of vertices. Now I need to make sure that each one of those vertices are connected and that there are no loops. So if we look at the 4 options on the right there, option C should stand out because there is a vertice that is in the top left there that is not connected to the others, and then on the right we've got a loop. So straight away, but without doing any maths, option C is not one of those. All right, that's not the minimal spanning tree because it's not a tree. So now we want to look at the other 3 and work out, well, what is our minimal spanning tree? So what we've got then, if we look at our main diagram, is I want to find out what is the smallest weighted edge. We're looking at all those numbers. 1. 1 is the smallest numbered weighted edge, so that's the first edge I'm going to put in my tree. Now I look at all of the other options. What is the next smallest number? Well, that's going to be the 2, so I can connect the 2 up there. My next smallest number is going to be 4, so I can connect up my 4 there. Now I'm left with a whole lot of options, 7, 8, 5, and 6. Well, I'm not going to look at the 6 because that's going to create a loop. So I need to look at 7, 8, and 5. Lo and behold, 5 is the smallest number of those 3. So that completes my tree. So which one of A, B, and D look like that? Well, it's not A, it's not B, it is in fact D. So the answer to this question is D. Question 14. Trapezium ABCD is shown below with side length AD being equal to side length BC, side length AB being equal to 6x, and an angle BAD equal to theta. which equation gives the area of the trapezium. So all of that information in that top part there was all marked on there. The only thing marked on the diagram that's not written up at the top there is that side length DC is equal to 4x. Now we want to find the area of our trapezium. So area of a trapezium is half of the top and the bottom added together and then multiplied by the height. Well, we don't have a height in our particular diagram at the moment. That's it there. All right, now I've drawn it in twice. Why have I drawn that height in twice? I want to draw your attention to the fact that there is a rectangle in the middle there, and then we've got two triangles. So our area of our trapezium, if we can just work out those three areas and add them together, we will get the same answer. So we want to find out our height. How can we work out the height of that particular triangle? Well, if between the two blue lines is a length of 4x across the bottom, across the top is also going to be 4x. What's the difference between 6x and 4x? Well, that's 2x. Each one of those 2x's, if I was to split them up, 1x would be from A to the first blue line, and the second x would be from the second blue line to B. So if we just look at our triangle on the left-hand side, we can put in an x. So now we've got a triangle where we've got an h, our height, and the length from A to that dotted blue line is going to be x. How does that help us? Well, we can write an equation for that triangle's area in terms of our theta. Right, so remember that tan of theta is equal to opposite over adjacent. The side length that is opposite our theta is going to be h, and the adjacent side is going to be x. So tan theta equals h on x. So now if I want to get h out by itself, h is going to be equal to x times the tan of theta. All right, all I've done with my tan theta equals to h on x, I multiply both sides by x, and we get that h is equal to x tan of theta. Well, that means I can substitute that in to my area. So my area is now the top, 6x, plus the bottom, 4x, times h, which we said was x tan theta. So 6x plus 4x, that's going to give me 10x. So it's a half of 10x times x tan of x. Well, half of 10x, well, that's just 5x. So we've got 5x times x tan of theta. 5x times x, well, that's going to give me 5x squared times the tan of theta. And looking at our options, that's going to be A. Last question of the multiple choice, question 15. The right triangle has a base length of 2x centimeters and a height of 8 minus x centimeters. What is the maximum area of this triangle? So this question here is a band 6 question, one of the hardest questions, and it falls in what is the common content between both standard and advanced. So advanced students would also have this question in their multiple choice. So what we want to do is work out the maximum area of the triangle. Well, what is area of a triangle? Hopefully we remember area of a triangle is half times base times height. Well, my base is just 2x and my height is just 8 minus x. So I can now multiply these things together. So a half times 2x, well, that's just going to leave me with x. And we're going to have x multiplied by 8 minus x. So if I wanted to multiply that through, what we're going to get is 8x minus x squared, but that doesn't help us any. I'm going to leave it like that, because what that is an upside down or sad parabola. So when we have a sad parabola, we can work out our maximum. So what that means is that for my x multiplied by 8 minus x, when will that be equal to 0? Right, because our area has to be a positive, we can't have a negative. So what's the minimum values that we could have? Well, if my first x was a 0, all of that would be 0. If my second x was an 8, well then we'd have 8 minus 8 is 0, so my total area will be 0. So therefore my values of x must be somewhere between 0 and 8, because if they were 0 or 8, they would be 0 as an area. We can't have that, so it's got to be somewhere between the two. Now when it says we want to find the maximum area, well, the maximum area is going to occur halfway between 0 and 8, and it always will. So that means halfway between the two is where x equals 4. That is when my area of that triangle is going to be the biggest that it can be. So when x is equal to 4, I want to substitute that back into my area equals x times 8 minus x. So when we substitute 4 into there, we get 4 times 8 minus 4. 4 times 4 is 16. So therefore, 16 centimeters squared is going to be the maximum area that I can have for that given triangle. So which one of those options is 16? Well, that's B. And that brings us to the end of the first video.